my name is Katie, and I am the driver for the session, and I'm here with.
Hey, this is Indo. I'll be the navigator for this session.
So today we are doing tutorial 5. Let me just plug this in. Right, let us begin. So let me just go out of here. So we'll be starting with our bootstrap folder, working from the top all the way to the bottom. Um, so here we just have our imports, and then over here, this file is basically going to load sample data when the Spring Boot application starts. It's also useful for having initial test data automatically to be inserted in a database. So here we have the annotation SLF4J. This just generates a log object for logging messages. And then we also have the annotation required constructor, generates a constructor for final fields, which will be the peer repository. Um, and the annotation component that makes the class discoverable and executed by Spring Boot. So if you take a look over here, basically everything, it's all over there at the bottom. This is a list of fake UPC codes used for the demo peer entries. So these UPCs simply act as unique product identifiers. So like peer 1 has this unique number, peer 2, peer 3, peer 4, peer 5, peer 6, peer 7 has all these unique numbers for to be identified. And then here we have the private final peer repository. This is just the injected Spring Data JPA repository for accessing the peer table. Here we have our override method. So it's going to automatically run after Spring starting up, and then it's going to trigger the loading of initial peer records. Okay, so take a look over here. We have the private synchronized void load peer object. So it's going to load the demo peers into the database only if it is empty. And then the synchronized just ensures that the method doesn't execute twice in parallel. Here we have the log debug loading initial data quantities via repository.count. This is just going to log the current count for debugging purposes. And here we have a if statement. So if peer repository.count is 0, it's going to prevent duplicates inserted and only load when the database is empty. Here we have the random new random. It's just going to generate a random price and quantity. Okay. So here we have each peer entries below following the same pattern. So it's going the one I'll be explaining everything follows along as it is exactly the same. So here we have peer name. As we can see here we have Mango Bobs. So the peer name is the name of the peer. And then we have the peer style. Peer style enum. This is the enum indicating the peer type. And then we have the UPC, the unique product code. So like for one, it will generate a unique product code. Now we also have the price. So price random. So it's going to give a random price. And then we also have the quantity on hand random next int. This is just the random stock number, and then we obviously have Paul as well as Paul. So this is everything. Nothing changes. Everything is the same. And then here we just have the private big decimal random price. This helper is to generate a valid price with two decimal places. You can take a look at the example over here. A random integer 1, 2, 3, 4, 5, and then a big decimal is 123.45. That is it for the bootstrap folder. Now moving on, we do have our domain folder. Here we're just importing the necessary imports. So the beer entity, it just represents a beer record in the database. This entity uses the UUID as the primary key, support optimistic locking, and it automatically stores timestamps and uses Lombok to reduce the boilerplate code. Here we have the annotation data, so it's a Lombok and it generates all the data set as the toString equals and hash codes. Another annotation called the no ask constructor. This is also Lombok, generates a no argument constructor. Another annotation called all args constructor. It's also Lombok as well. It generates a constructor with all the fields included. And then we also have the annotation builder, Lombok as well. It provides a fluid builder pattern for object creation. And then also we have the annotation entity. It's to a database table. So moving in our class, I'm just going to highlight us up here. So the primary key in this case is the UUID. Um, so the UUID are globally unique identifiers. And then we also have the generated value. That is just a custom generator that creates a UUID automatically. We also have type over here. So the annotation type ensures that the UUID is stored as a 36 character string instead of a binary. And then also we have column definition. So, sorry. This is varchar. It also ensures that the portability across databases. Here we have the annotation version. So version field for optimistic locking. It automatically increments when updating records, and it also prevents multiple users from overwriting each other's updates. Here we have private string, the name of the beer. Here we have examples of Heineken and Corona. Um, Private string beer style enum. This is the enum defining the beer style, IPA, larger, AL, etc. Private string UPC, the universal product code, a unique product identifier. And then also we do have the private integer quantity on hand, the quantity available on hand, which is the inventory basically. And then also we have the private big decimal price, the price of 1 unit of beer stored in the big decimal for accuracy. Next, we do have the annotation create timestamp, annotation column, updatable, and then private timestamp created date. So this is the timestamp when the record was created. It automatically sets by Hibernate and cannot be updated manually. And then we also have the annotation update timestamp, private timestamp, last modified date. Timestamp for the last update automatically updated whenever the entity changes. Moving on, we have customer. So the customer class represents a customer in the system. Note this class is not marked with the entity, which means it is not mapped in the database table. It is currently simple, POJO, plain old Java object, likely used for API payloads, in memory storage or demonstration purposes. Okay, so we just have all our annotations that I already got over. So here we have the private UUID ID, so that's easily unique identifier for each customer. The UUID is used instead of the numeric ID for better uniqueness, better support across distributed systems, and no DB sequence needed ID is generated anyway. And then also we have the private string name, the customer's name could and it could represent the first name, full name, etc. So we are done with the domain. Moving over here, the peer repository. Here we're just importing all the necessary imports. Okay. So the peer repository. This interface handles all the data access related to the peer entity. It extends the JPA repository, which provides the CRUD operations, say find priority, delete, etc. Pagination support, sorting support. Spring Data JPA automatically generates and the implementation at runtime. So page peer find all peer names, string peer name, pageable, pageable. This is just going to find peers by exact peer name with match with pagination. And then here we have an example. Find all peer name like Galaxy Cat, page request of 0 and 20. That's an example. Then we have our annotations param. So param, peer name, the peer name to search for, param, pageable, pagination, and sorting information, and then the return, a page of peer results. Next, we have page peer find or peer style enum, peer style, pageable, pageable. So it's just going to find peers filtered by peer style with the pagination. Example, find all peer style enum dot IPA page request of 0 and 10. We have our annotations for RAM, peer style, the enum style of the peer IPA style, etc. The annotation for RAM, pageable pagination, and sourcing information. And then obviously we do have our return, which is the page of the peer results. And then we have page peer find all by peer name and peer style. String peer name, peer style, inner peer style, pageable, pageable. So this is just going to find peers matching both peer name and peer style with the pagination. This also uses Spring Data JPA's query method naming convention to automatically generate, select all from the peer where peer name and the peer style. So here we also have on annotations param peer name. It's going to name the folder annotation param peer style, the style folder, annotation pageable pagination, and sorting the information in the return a page of peer results. Lastly, we have peer find by UPC string UPC. So this is just going to find a single peer and its UPC, which is the unique product code. UPC values are unique, so this returns exactly one peer or null. The annotation param UPC, the UPC value, used to identify a peer, and the annotation return in the peer with the matching UPC or null if not found. That is it for our repository folder. Moving on, we do have our services. Okay, so the beer service, this interface defines the contract for all business logic related to beer. The controller calls the service layer, not the repository directly. The responsibilities fetch peer data with optional filters, create or update the peer records, convert between peer entity and peer TTO, handle pagination, optionally hide inventory values depending on the API request. The implementation is provided in the peer service IMPL. So here we have the peer page list peer, string name, peer style, in a page request, and the boolean show inventory on hand. So this will return a paginated list of peers, and it also supports filtering by peer name, which is optional. Filtering by peer style, also optional. Pagination, page number, and size. Optionally include quantity on hand in the result. Um, so here we have the annotation param peer name optionally filter by name. Annotation param peer style. Optional filter by style, IPA, style, etc. Annotation param page request, pagination information, page number, and size. Annotation param show inventory on hand whether to include the inventory count in results, and then the return will be a beer page list containing beers in the pagination metadata. Okay, so here we have the beer DTO, get by ID, UUID, beer ID, boolean show inventory on hand. So it's going to fetch all the beers by its UUID. Um, we do have beer ID, which is also a param, the unique ID of the beer. Show inventory on hand whether to include quantity on hand, and then the return will be the beer DTO representing the found beer. Now we have 1 second. Now we have the beer DTO save new beer beer DTO beer DTO. So it's going to create and save a new peer record. The DTO comes from the API input, gets converted to an entity saved, then converted back into a DTO for the responses. The annotation param peer DTO, the data for new peer, and the return will be peer DTO containing created peer with the ID. Um, Here we have the peer DTO update peer UUID peer ID peer DTO. So it's going to update the existing peer with new values. The peer ID is the ID of the peer to update. Peer DTO update the field with the values, and then it will return the updated information. Now we have peer DTO get by UPC. So it's going to retrieve a beer by its UPC, the unique retail barcode, and the UPC code to search by, and then it will return the beer DTO representing the matching beer. Lastly, we do have the void delete beer by ID. So it's going to permanently delete a beer by its ID, and then the param beer ID is the ID of the beer to delete. So now we are done with the beer service file. Now we do have the beer service IMPL, which is basically the implementation of the beer service. So this class just contains all the business logic, fetching pagination peers, filtering by name and style, mapping between the beer entity and the beer DTO, enabling caching for performance in creating, updating, and deleting the peers. So here we have final peer repository. So this is just a JPA repository for the database queries. Private final peer mapper. This just converts the entities to the details. Okay, so here we have catchable, catch name, peer list, and catch with a condition with the inventory on hand. And then we also have our override method, and then also the peer page list peers with peer name, peer style, page request, and show inventory on hand. So it's going to return the paginated peers optionally followed by name of style. Now we do have the catchable. This is just going to catch only when inventory is not requested. Inventory changes frequently, so caching is disabled for it. We do have our filtering logic, so both name plus style, which is only name, only style, or no filters to fetch all. Lastly, the big nation is just there to handle page requests. So here we have a if statement. It's going to determine which filter to use. So if not string utils are empty, be a name, and not string utils is empty, be a style. And then also be a page, be a repository, find all their by name and style. So it's just going to filter both name and style. So if it is empty, filter both by name and style. We do have our else if statement, so if not string utils is empty, which is the beer name, filter only by name. For the beer page, beer repository, find all by beer name. Another else if statement, if the string utils is empty, and then we also have beer page, beer repository, find all by beer style. Filter only by style if the beer style is empty. Oh, sorry, if it is not empty, then filter all by style only. And then we also have another else statement. Peer page, peer repository, find all. No filters, just return all the peers available. Here we have a if statement again. So if the inventory is requested, included in the DTO. So show inventory on hand, peer page list with all the get the peer page list with the content, stream the map, and collect the list. And then also we just have a page request. And then yeah, we also have an else statement. So peer page list new peer page get content stream map, and then also collect the list. So if the inventory is not requested, use the lightweight DTO. And then also just return the peer page list. So here we're going. So here we have the catchable catch name peer catch. The key, which is the peer ID, and in a condition for the inventory. And we also have override method. Get the peers by their unique ID. Okay, so we also have our exceptions. And then also a return. So we have the catchable. This is just going to cache only when showing inventory on hand is false. And then if the beer doesn't exist, throw in error, and then also the param UUID. And then it must show the inventory on end with to include the inventory on. And then here we just have another method, the override public peer save new peer. Um, so here it's going to save a new peer. It's going to convert it to a DTO entity, save the repository, convert the entity into a DTO. So we do have here peer, peer mapper that is just going to convert the DTO into an entity. And then we also have the peer save peer. It's going to save the peer in the database, and then it's just going to return the DTO. So this is where we will be updating an existing peer. So public peer DTL update peer. Then we also fetch all the peers, update the peers by the name, the style, the price, the UPC, save a peer and return the peer. Oh. So fetch one. So step one is fetching an existing peer, and then step two is to update the fields. So the name, the style, the prices, set UPC, and then the third step is to save the peer, and then the fourth step will just return the updated DTO. Here we do have public bear DTO get by UPC. So you're just going to look the peer by its UPC, which is the barcode, and then caching enable because the UPC never changes. And then lastly, we do have a delete peer by ID, so it's just going to delete a peer by its ID and there will be no return value. So you may have the customer service. Um, so the service interface for customer operations. This interface defines the contract for all customer-related business logic. The implementation class will handle fetching customers, creating a new customer, updating an existing customer, and deleting customers. It uses the UUID, which is a unique identifier for customers. Here we have customer detail, get customer by ID. So it's going to retrieve a customer by the unique ID. The customer ID is the UUID of the customer to fetch. The return will be the customer's detail containing the customer's details, and it will throw an exception if a customer does not exist. Here we have customer details, save new customers. So it's going to save a customer to the database. Um, so we do have steps for it. So step one will be convert customer detail into a customer entity. Step two, process entity via the repository. Step three, convert save entity back to the customer's DTL. And then we do have the customer DTL, the DTL representing the customers to create. And then I return customer DTL of the newly created customer, usually including the generated ID. Here we have the void update customer UID, customer DTL, customer DTL. So um, it's just going to update an existing customer. We also have steps here. So step one will be to find the existing customer by the ID. Step two will be to update the fields from the DTL. And step three will just be to save the changes to the repository. Lastly, we have void delete by ID. So this will just delete a customer by the unique ID. So step one will be find the customer ID, and then number two, delete it from the repository. So now we are going over the MVC exception handler. This would just try exceptions if there is a violation. So like validation, error handling, it's a straightforward file, and if there's a request, it will list all the exceptions. Next we also have another file called no found exception. So this will just throw an exception if nothing was found during runtime. So now we have the controller. I will explain via um sorry, I'm confused there. I'll explain via Insomnia. So in the controller we do have our get methods and all that. So I'll just explain it and I will test it through Insomnia. So just ignore the rest for now. I do have errors, but I will get rid of it. Okay. So this is the REST controller for managing the peer resources via HTTP endpoints. Um, Thus is the default pagination values used when client doesn't specify page numbers or page size. Here we just injected peer service handlers, business logic and data access. So here we have our get mapping. Page number, page size, peer name, peer style, show inventory. So this is just an API to get a peer. It's going to return a paginated list of peers, optionally followed by name, style, or inventory flag. Query parameters, page number, page index, which is the default starts at 0. Page size, number of items per page, default is 25. Page name followed by name, peer style followed by peer style, and show inventory on hand, include inventory count if true. So here we apply the values if the parameter is missing, and then this just fetches all the big native peer lists. Here we have another get mapping, so it's going to get an API for the peers, retrieve the single peer by its UUID. Another get mapping, it's just going to retrieve the peer by its UPC code. Here we have our post request. It's going to create a new peer record, and then the request body will be the peer DTL, which is validated, and the response will be to one created with a location pointing to the new resource. Here we have a put request. It's going to update the existing peer by to UID, the request body peer TTL, and the response will be a 204 no content. And then lastly, we do have our delete, so this will just delete a peer by its UUID and the response 204 no content. So we're going to test it out with Insomnia now. So now we're going to create a beer. So this will be a post request. So we have the beer name, we have the beer style, we have the UPC, quantity on hand, and the price. So there we do have our 201 created. Next, we're going to list the beers. Um, so this will be a get request. Here we have all the beers with their ID, beer name, beer style, UPC, price, quantity on hand, created it, last updated it. Okay, now we're going to get a beer by its unique ID. So this is the unique ID of a beer that we do want to get. Let me see. Okay. I'm just taking this ID to get it to work. Where is this thing? Oops. Okay, so I'm just going to put it over here. So we want to get a beer by a ID. So I'm going to add this in, take this ID, and I'm going to insert it over here. Here we have a 200, okay, so here we got the beer, Mango Bob's, LA, with all those information. Now we are going to update this beer. So this will be a put request. Um, and we're going to send it. And we do get a 204 with no content. Then lastly, we will be deleting the beer. So just with the unique ID. So I'm going to put a delete request and it should work now. As you can see over there, 204 no content. So that's it for the beer controller. For the customer controller, it is a REST controller for managing the customer's resources via HTTP points. So here we just inject service layers that handles the business logic for custom operations. Oh, here we create the constructor-based dependency injection recommended for the immutability and testability. Next, we do have our get mapping. So here we will just get customers by the EU ID, and then we also have the post request. This is just going to create a new customer in the record and validate the customer's data in the request body. And then we do have the put request, so it's going to update an existing customer by the UID, and then a delete will just delete the customer, sorry, completely. So I will be using Insomnia. Okay. Okay. So we will be getting a customer by the unique ID. Before getting, we have to create one. So oh, false request. Sorry. Your customer was created. Next, we're going to have to update the customer. Sorry, get the customer by their unique ID. So here is the unique ID that I will be using. Um, got a status 200 okay with a user and the ID. Okay, so now that we got that, we will be updating this customer, so it will be now a push request with the user's unique ID. So there, just update it there. Make it a put request. We'll use these details, I guess. And the ID, of course. We did get a 204. Now we will be deleting the user with the unique ID. So we will be sending a delete request. And we got a 200. Okay. Okay, so we are done with the controller. Now we have the mappers. So over here in the mappers, we have the mapper interface to convert between custom entity and the customer's DTL. And then a map struct will automatically generate the implementation at compile time. This interface allows seamless conversion between the internal domain model and the API transfer object. Next, um, here we convert a customer detail typically from the API request to the customer's entity. So the DTL is the customer's object from the API input, and it will return the entity ready for persistence. And then lastly, we do have customer DTL. So this is just going to convert a customer entity from the database to a customer detail, which is suitable for returning the API responses. Next, we do have the date mapper. Um, it's a utility class to map between Java SQL timestamp, Java time, and offset datetime. Often used in maps, struct mappers to convert database timestamps to API friendly and offer set date time values and vice versa. Okay, so here we are converting the Java SQL timestamp to the database. We have the param which is the timestamp object from the database, and the return will be the equivalent offset time from in UTC in null in or null if input is null, and then this will just convert the timestamp to local time and also daytime at UTC. And then lastly, we do convert the offset datetime API friendly to Java SQL timestamp database friendly. So the offset is the object from the API to DTL, and it will return the equivalent timestamp for null input if it is null. And then we do have a model. So here we do have the private UUID, the unique identifier of the peer. Null ensures that the clients cannot set it when creating a new peer. We have the private string peer name. Name of the peer must not be null or empty. Peer style of a peer must not be blank. Private UPC, universal product code for the peer. Big decimal, which is the price of the beer, and the big decimal ensures precise monetary calculations. And then also we do have the quantity on hand, current stock quantity of the beer. Uh, then when the timestamp of when it was created and when it was last updated. So here we have the beer page list. This is a wrapper for the paginated list of beer detail objects. It extends the Spring Data page to provide the backnation functionality, and then it also serialized implementing so this can be safely sent over to the network. Okay. Here we have our constructors used by the Jackson JSON deserialization. So content is a list of the objects on the page. Number is the current number. Size is the size of each page. So the element is the number across all the pages. Pageable is the additional pregnation information. Last is whether it is the last page. Total page is the total of pages. Sorting information is the sort. First is with this is the first page. And then the number of elements on the page. And then here we have content, which is the list of the peer objects, and then the pageable is the pageable object with the page number and the size, and then the total is the total number of elements across all pages. This is just a standard constructor. And then we do have another constructor, public peer page list, the constructor for a simple list without pagination information. We do have our peer style enum. Um, this is just going to represent different peer styles. So we do have all our beer styles with information, I guess, and apparently how they taste. And then we do have customer detail. I am rushing as this video is a bit long. Um, Introduce the data transfer object for the customers. So here we have all our annotations. Private UID is the unique identifier of the customer generated by the backend or the database. Now blank validation fields, the size, another validation to ensure that the name length is 3 and 100 characters, and then the string name must be the name of the customer. And that is it for tutorial 5. It is quite a long tutorial. Thank you for watching. Oh my goodness.